Hey guys, and welcome to After Hours Academy, where I'm here at 2 a.m. and so are you, so let's just make this easy. And I thought a great first video for statics would be something like using position vectors and unit vectors to find different force vectors, just like this example. And I know this example is pretty simple, and it is, but I promise once you know this concept, you're going to be able to apply it to pretty much any problem of this type you get. And that could be 2D, like this XY plane we have here, or it can even be 3D. And the components of this problem, it's usually going to include these points with some coordinates, with some lines in between them, and you're going to have a force vector that you're going to need to find. And you're going to be provided with this magnitude of this force. So for a vector, we're going to need a magnitude and a direction, right? So luckily we already have this magnitude provided, and now all we need is the direction. And luckily for us, this force is going to lie along a certain line. And in this example, it's going to be from A to B. And so since this line is parallel to this force, all we have to do is grab the direction from this line and then apply it to this magnitude here of the force, and we're going to have our force vector. Super simple. So the first step we're usually going to want to do is find the position vector. And that is just a fancy word for a vector that lies between 2 points, that goes from one point to another. And in this case, it's going to be written like this. All that tells us, this arrow tells us it's going to be a vector, and then this is just describing the direction it goes in. It goes from A to B. And that is going to help us know how to find the position vector, because what we're going to want to do is we're going to subtract the initial point from the final point, where it ends up. So all we're going to do is we're going to take B, and we're going to take the coordinates that we have here, and then we're going to subtract A from it. And after that, it's just going to be a simple subtraction problem, and we're going to end up with our position vector. And one quick note before we do this, usually when you write a vector, you're going to want to differentiate it from a point somehow, because for a point, you'll usually use parentheses to write it. For a vector, they'll usually want you to use either brackets or this little pointy thing. And I usually use this because I just hate brackets. They're so hard to write. So it's just going to be simple subtraction from here. We have 8 minus 2 is 6, negative 7 plus 4 is negative 4. 6 minus 7 is negative 1. And as easy as that, we have our position vector. So now the next step we're going to want to do is find our unit vector. And to kind of explain a little further what this is, by the way, this is usually how that's going to be written with an E. We'll just write out some quick examples of what a vector can be. So if this is our magnitude and this is our direction, right? Say we have 180 newtons and it's going this way. That's our magnitude and our direction. Let's say we have 2 meters and this direction. That can also be a vector. But what if we just have one? Just one unit, unitless, and it's going this way. Well, it still has a magnitude and a direction, so it's going to be a vector. So what that means, since this magnitude is going to be 1, 1 times anything is going to be that thing. So if we just multiply the magnitude of this by 180, then we can just grab the direction from this line, make the magnitude what we want it to be, and boom, we're going to get our force vector. As easy as that. So how we're going to want to do this, how we're going to want to find the unit vector, is we're going to take our actual vector, AB, and we're going to divide it by the magnitude of that vector. And all these absolute value things are saying is that we're finding the magnitude. So this is going to look like 6, negative 4, negative 1. And then to find the magnitude of a vector, we are going to want to take every component. We're going to square it, add it together, and just put it under a square root. Super simple. So we're going to have 6 squared plus negative 4 squared plus negative 1 squared. And that is going to be, I'm going to have to get out my calculator. Shoot. Okay. 36 plus 16 plus 1 squared, or square rooted. That's going to be about 7.28, pretty sure. And now all we're going to do is we're going to divide each component, 6, -4, and 1, by 7.28. And I guess I'll just go ahead and do that. 7.28, 0.82, 0.55, just rounding here. And our last one is going to be 1, 4. And that is going to be our unit vector. And you remember how the unit vector was, well, unitless. A quick example of how that works, because I kind of feel like explaining it. So this is going to be a different example. We're just going to make this up. So say we have a random force vector. So let's just make it 2, 2, 2, and it's a force vector, so its units are going to be newtons, right? And let's say the random magnitude of this force vector is going to be 2 newtons. And so if we're dividing the vector by the magnitude, we're going to find the unit vector. And you'll notice in this equation, these units are going to cancel out. And if we divide, we're going to get 1, 1, 1, unitless, and this is going to be our unit vector. I hope that makes sense. I just kind of wanted to explain why it's unitless, because that's something I did not get at first. Okay, so we are so close to finding the answer to this problem that we need. All we have to do, we're going to find F, the force vector, and we're going to multiply the magnitude of that vector, 180 newtons, by this direction that we have here, that we just found. So while it does have a magnitude of 1, it's just going to be used for directional purposes. And I guess I'll use my calculator for that too. 0.82 times 180, 147.6, 155 times 180, yeah, if anyone's watching this and you don't care about me getting the exact numbers, that is totally fine, because I would be happy not to do that. So here's going to be our vector, and we can't forget the units. Oop, that's supposed to be an n. And that's going to be our force vector. It's, yeah, it's pretty simple, pretty easy. And you may see some other problems that are 3D examples. Maybe different examples like, oh, a hot air balloon is pulling up a few cables and there's tension forces in each of the cables. Find this force. You know, it's going to be the exact same process. And maybe I'll go ahead and do a quick example of that just to illustrate. Okay, so say we have a hot air balloon and it's going to hold up 3 cables just like this. And this is going to create tension forces in each of these cables. Just like that. And this point at the very top, that's going to be point A. Down here is B, C, D. Just like that. And we're going to just choose some random points for this. Okay. Yes, just random. And it's going to ask us to find one of these tension forces, or all of them. So let's just get a magnitude here. I don't know what is with me in 180 today. I haven't thought about this number in forever, but I'm just using it all the time now, I guess. Okay, so we are going to want to find that force vector right here. So The first step, of course, is the position vector. So we're going to say, it's going to be AB again, I guess. That's going to equal B. And we're going to subtract A. Whoops. 8, 3, 7. And that is going to be equal to, what am I saying? Can I do math today? And that's going to be the position vector. Then we're going to take this, -7, -4, -6. We're going to divide it by the magnitude, 7 squared plus -4 squared, 6 squared. And let me just go ahead and do that on my calculator so you don't have to watch me write it all out. 49 plus 16 plus 36 under square root. Let's just say that's 10. It's going to make it a lot simpler. And all these divided by 10, well, I guess I could just move the decimal over. And there's the unit vector. And last step, we're just going to multiply 180 newtons. Yeah, I really did make this just like the last example, didn't I? I guess I'm just trying to prove the point that this can just be applied to any scenario. And I don't really feel like calculating all that, but you're just going to multiply 180 by each of these components. And it's going to have newtons. That's going to be the units. So let's think. So the last problem I think that this is used with a lot is with pipes, like in plumbing. That's also a pretty common way I've seen it illustrated. Let me just furiously erase here. And this is also going to be in a 3D environment. So this is going to be our X, Y, Z. So let's say we just have a pipe and it's coming this way. And then it's going to come in the Z direction a little bit, and it's going to come down in the Y direction. And let's say this first point right here is going to be 0, 0, 0. And then let's just say we came 5 units in the X direction, 5, 0, 0. And then let's just say we came 5 more units in the Z direction, and then -5. We just came down in the Y direction. And we are going to want to find a force that goes from here to here. And that's going to be, let's change that up a little, 60 newtons. For finding out this force vector right here, we're just going to find the position vector from this point to that point, or the other way around, I guess. So we just take 5, 0, 5, and we're just going to subtract 0, 0, 0. And then we're obviously going to get 5, 0, 5 position vector, and then we're going to get unit vector for that. 5, 0, 5, and then we're going to divide it by the magnitude. And you get the point. I won't do the problem 3 times. So yeah, I hope that helps in your problems. I hope that was a good introduction to both position vectors and unit vectors. Definitely, I would say definitely remember unit vectors, because that's going to come in handy a lot throughout the rest of the course. So thank you for watching. I hope you learned something. If you have any constructive criticism, comment, that's fine. And yeah, I guess if I do another video, I'll see you in that one.